Hello guys, today we're going to be solving cheapest flights with K-stops. So this question basically gives you an array. I think the array contains from to, which is, so it will be like an edge and where it goes to and how much it costs to go there. I think the nodes always go from 0 to 3, so it's always like ascending order in that method. And what else do we need to know? So we just have to, we're given like a source, a destination, and we have to figure out the fastest way to get to that destination in K moves. So the algorithm is just, you want to make a queue where you basically add the cost and the destination in it, and then you're going to keep expanding the queue and put in more things in it. And for example, this to this is going to be 100 and 600, and then we're going to have like a loop that goes through why things exist in the queue, or while K is not equal to, what do you call it, we're not equal to K, I guess. So this is basically going to be like BFS. So this, the first level is just going to be this, and then the second level is going to be going to 2 and 3. And yeah, you'll kind of understand when I start coding it. To start off, we just need an adjacency list. I think I'm just going to make an empty adjacency list for underscore in range n, which they've given us the number of nodes, and then we need to populate it. And to do that, we just have to do for u, v, w, and flight. We're gonna say adj u. So we already know u is always going to be 0 to n basically. And we could do the append a tuple vw. Yeah, and that should pretty much populate the adjacency list. And then what we want to do is just initialize the queue. So just deck, and I guess we also want to do an array. So we basically want to find out the fastest time it takes to go to a particular destination. So we're gonna have another array that's also the length of the nodes, and that's just gonna keep track of the fastest time it takes to get there. So I guess we could just call it mean this or something like that. And then it's just gonna be an array that contains an empty float. So float infinity, and then we could do the for underscore in and length range n, and that should just put the maximum possible max value in there. Yeah, and then we just want to actually put something in the queue. Actually, queue queue dot append, and we want to throw in the source node and how long it takes to go to the source node. So it's going to be 0 and source and 0. And then now we just want to go while queue. So while there's something in queue, and we also want to make sure that oh yeah, we haven't actually done that. So we want to keep calculating the stops, which is equals to 0, and while stops less than or equal to k. So that's how many stops you can do. And yeah, so we pretty much want to pop whatever is in the queue. Actually, we want to loop the number of the queue, BFS, for, I guess, what's the queue, what's these things, S and cost, I guess node and cost in queue. For queue. We're gonna do queue node cost equals to queue dot pop left. So we're just popping whatever is in the queue, and that should give us the node and the cost. And then what we're gonna do with that, so we're gonna use that to get the adjacency, like basically get all the neighbors in the queue. So for so oh yeah, that's where we use the adjacency. That's for n in ADJ, and that takes in a node. No, I don't know why I put a string in there. Node. We basically, for each neighbor, we basically want to put that in the queue. The append n. Oh no, we gotta put in n and the cost, basically the current cost, and whatever we get from the adjacency. So adjacency list, we put in VW, which is, I guess we could just call it VW because that'll be a lot easier. And it should be cost plus W, and yeah, we just want to put in V actually, not N. And what else do we need to do? We do need to increment the stops plus equal 1, and I'm trying to see if I'm forgetting anything. Yeah, I think oh yeah, we also need to check if we need to update the minimum distance. So if I guess we could just do that here. So if cost let me just do it. I'm just trying to wonder where I should do this, but basically if cost is greater than plus W is less than I don't know, min dist, V, then I guess min dist V equals to cost plus W. And we got this, we basically append the stops, and we return -1 if float min dist destination else -1. else, just return in this destination. Yeah, let's see what mistakes I've made. So this is the code so far. I'm trying to see if I'm missing anything. Time as one if min this equals float else min this. Oh, yeah. Range. I always do this. I forget to write the range. It's honestly not convenient writing range in Python. And let's submit it and hope it actually works. Yeah, so basically I was appending into the queue even if I was appending stuff even if we weren't cost plus W wasn't lower than the minimum distance, which I should have done. But pretty much that's it.